Now let's look at the formulae which relate the trigonometric ratios. Say for example, the first one, I'll start with again the right angle triangle. Okay, suppose this angle is theta, right? This is ABC. What is sine of theta? Sine of theta is very clearly, you can see, it is AB upon AC. What is cos of theta? Cos of theta is clearly BC upon AC, right? Now, what is Pythagoras theorem? Pythagoras theorem is AB square plus BC square is equal to AC square. Divide by AC square in all of them. What do you get? If you divide by AC square on both sides, this is what you get. That means the left hand side is AB upon AC whole square plus BC upon AC whole square is equal to 1. Now there is no need to do this derivation, but this helps you to understand all square relations. Remember, I was talking about square relations. There are three types of relations. The first one is square relations, right? So here we have AC, we divided by AC, we got this. Now can you see that AB upon AC is sine theta? So sine theta square plus BC upon AC is cos theta. So this is cos theta square, right? Oh, great. So the way of writing this, that this power can be written before the angle. This power can be written before the angle. Just to explain it clearly, if I have cos theta to the power 5, it can be written as cos to the power 5 theta. If I have cos theta to the power 2, it can be written as cos square theta, like this, you know, and so on. So this can also be written as, so this expression can be written as sine square theta plus cos square theta, that is equal to 1. This is the first and the most important rather square relation. Now what you can do is, you know, we started with this formula where we kept AC on this side. If I keep BC on the other side, if I keep AB on the other side, I'll get the other two formulae, and they will be something like this: sec square theta minus tan square theta is equal to 1. Okay, and cosec square theta minus cot square theta will be equal to 1. So these are the square relations which is there for trigonometric ratios. Now this also can help you in the previous question that we just did. There the cos theta value was given. Put it here, you would get the value of sine theta. Once you get the value of sine and cos, you will get the value of sec and cosec. And from any one of them you can calculate tan and cot, right? Now here only, so square relations are the most important ones because you will be needing them once to convert from one to the other. Do you realize that if you remember these formula, if any one of them is given, you can calculate all the others. That's the beauty of this. And that is without getting into the diagram, because this would be true for any triangle, any angle, all right? Or any angle value. The triangle actually doesn't matter. Right angle was required for definition. Once you understand the definition, then these relations are independent of anything, right? Independent of any other information. Okay, you can just use any angle, you put it here and calculate this. So one of them is given, you can calculate all the others. So this is the square relation, right? Now the second type of relation that we said earlier was the inverse relation, but that you already know. I just write them. Inverse relation means one of them is inverse of the other, and there are three such pairs. For example, cosec theta is 1 upon sine theta for any value of angle. Okay, sec theta is 1 upon cos theta, right? Cot theta is equal to 1 upon tan theta. This is inverse relation. This you already know. And one interesting part is the ratio relation. That is what we said in the last sentence of the introduction part. That is, tan theta can be written as sine theta by cos theta for any angle. Just remember this theta has to be the same, right? Similarly, cot theta can be written as cos theta upon sine theta. So this is the ratio relation. So what you see on the board right now is the complete set of all formulae that is required, in fact more than required, for your MBA entrances. Okay, now for the understanding, again I wanted to solve this question but without using triangle, only using the formula that you have learned. You know, tan theta is 2 root 3 by 5. You do it with the triangles, but right now I want you to do it with formula. Pause the video and come back to it. Other t ratios for theta. So how do we go about it? Remember, as I said earlier, the square relation has to be used once and only once. Okay, so one of the square relations will be used only once here. How do we use it? Involving tan theta, what was the relation that we had? Sec square theta minus tan square theta equal to 1. Oh, great. So sec square theta is equal to 1 plus tan square theta is 2 root 3 by 5 square. That is 4 3s are 12 by 25. Great. So this is 37 by 25. So what do we have? We have sec theta is equal to root 37 upon 5. Don't worry about the sign as of now. It will come as and when it is required. You don't have to worry about it. Okay, so right now let's focus only on the positive value. So the positive value of sec theta is root 37 upon 5, right? The moment you have sec theta, you can calculate cos theta. Cos theta will be inverse of sec theta, that is 5 by root 37, right? You already had tan theta, so from there cot theta will be inverse of tan theta, that is 5 by 2 root 3. Okay, again focus, square relation has to be only once, we have already used it. Now we have tan theta and cos theta. From there, do you see that tan theta was actually sin theta by cos theta, right? So from here, sin theta will be equal to tan theta into cos theta, right? And what is tan theta? Tan theta is 2 root 3 by 5. What is cos theta? 5 upon root 37. Great. So we have 5 cancel and we have sin theta is equal to 2 root 3 upon root 37. As I said earlier, you could have used triangle also. But right now, to focus on the formula and remember the formula, this is how we can use them. Okay. Then once you get sin theta, then cosec theta will be inverse of sin theta, and that is root 37 upon 2 root 3. So for any given angle, if one ratio is given, you can find all the other ratios. Now let's look at the next part, which is the values of trigonometric ratios for specific angles.